So in the last lesson you should have done quite a lot of simplifying of surds and some collecting like terms. So today we're going to do multiplying out brackets for surds. You multiply out brackets for surds exactly the same way you multiply out any other double bracket. So you'll be very familiar with multiplying brackets out like this. And I know we've spoken about the order that we do it in, and you don't like the order I do it in, and I don't like the order that you do it in. But do whatever order you like, as long as you multiply both terms in this bracket by both terms in this bracket. So if I multiply this out, I get x squared plus x plus 2x plus 2, and then I collect the like terms. So I get x squared plus 3x plus 2. Exactly the same method for expanding double brackets where you've got surds. So we've done these two multiplied together. We've done these two multiplied together. We have done these two multiplied together. And we've done these two multiplied together. So every term in this bracket has been multiplied by every term in this bracket. If I do the same then with double brackets but with surds in, I'm going to multiply it out in exactly the same way. I'm going to do 1 times 2, so that's 2, plus 2 root 3, minus root 8, and then minus, because it's a minus and a plus, root 3 times root 8. Can't currently collect any like terms. This is just a whole number. This is a surd with root 3. I can't collect it with this because this is root 8 and it's a subtract, so I can't just do root 3 minus 8. That wouldn't make sense. So what I want to do is multiply this and then see if I can simplify that at all. So I'll have 2 plus 2 root 3 minus root 8 minus root 24. I can simplify this. I can also simplify this. So this is going to be 2 plus 2 root 3 minus, I want to turn this 8 into a square number multiplied by another number. And the same with 24, I want to turn it into a square number multiplied by another number. So this is where I'd got to. I'm now going to work with these surds just like we did in the last lesson. So 2 stays the same, 2 root 3 stays the same. This is minus root 4 times root 2 minus root 4 times root 6. So I get 2 plus 2 root 3. Root 4 is 2, so that's 2 root 2 because the root 2 stays the same. And again, root 4 is 2, so it's 2 times root 6. I cannot combine any of those terms together because they're different surds and this one has no square root. So this is the final answer. So if I multiply out 1 plus root 3 into 2 minus root 8, my final answer is all of this here. That is everything you need to attempt exercise 4 on the sheet that I've put up. So now I'm going to go through what you need to do exercise 5. So the main reason we've been working with surds and multiplying out brackets is so that we can rationalise the denominator of an expression or a term. Rationalising a denominator means when we've got a surd in the denominator, we want to change that denominator so that it is just an integer. And we'll do that by applying the same change to the top as the bottom of the fraction. So, for example, if we had a fraction that looked like this, the denominator is currently an irrational number because it has a surd in it. So we want to rationalise it. We want to turn this into a rational number. The way we're going to do that is if we multiply the top and the bottom by root 15, that is fine to do because root 15 over root 15 is 1. So really, we've multiplied this fraction here by a fraction that is the same as 1. If I do this, I'm going to get 5 root 15 as my numerator, and I'm going to get 2 times root 15 times root 15. Root 15 times root 15 is just 15. If you times a square root by the same square root, it gives you the square, so it will give you 15. So that will be 5 root 15 over 2 times 15 is 30. And then, as we always do with fractions, we're going to try and simplify it. There's 5 here. I can cancel that with the 5 that makes 30, turn that into 6. So root 15 over 6 would be our final answer because 30 is 5 times 6. The 5 cancels and leaves us with 6, and that is our final answer. Something to note in that example that we just did, you do not need to worry about the 2. If the denominator is just a third multiplied by something, you don't need to worry about that multiplier. You just need to multiply by the square root over the square root and ignore the 2 in terms of setting up this fraction to multiply by. However, in the next example, we will need to worry about the constant term. So let's do that now. Where we have an expression like this, we've still got an irrational denominator because there is a third. We cannot express this as an integer or a fraction with integer parts. So this denominator is irrational. We want to multiply this by something to turn this into an integer, and we will multiply the numerator by the same thing. When we do this sort of calculation, the denominator that we're going to multiply by to rationalise this will always have the same 2 terms, so 1 and root 2, but we change the sign. So we're going to multiply this by this. We're going to have the same in the numerator because we need to be multiplying this fraction by 1. This divided by this, it's something divided by itself, so this fraction is 1. That's why it's fine to multiply this fraction by it, because we are just multiplying it by 1, but it would change the format of this fraction, but not the value. So this is why you were multiplying out double brackets, because the numerator is going to become 2 plus 2 root 2 over 1 plus root 2. So that's going to be your numerator of your new fraction. Denominator of your new fraction will be 1 minus root 2 over 1 plus root 2. So this was the line we had got to. So what I need to do is multiply out the top and the bottom. So on the top, we're going to have 2 plus 2 root 2 plus 2 root 2 plus 2 root 2 times root 2. Then for the denominator, I'm going to have 1 minus root 2 plus root 2 minus root 2 times root 2. Then I want to simplify the numerator and I want to simplify the denominator. So I've got 2 root 2 plus another 2 root 2. So this is the same as if I had 2x plus 2x, where x is root 2. If I added them together, I'd have 4 lots of x. So here I've got 2 lots of root 2 and another 2 lots of root 2. So altogether I've got 4 root 2. This bit on the end, I've got 2 times root 2 times root 2. So the root 2 times the root 2 makes 2, and then multiplying that by 2 makes 4. In the denominator, I've got 1 minus root 2 plus root 2, so they cancel each other out. And then I've got root 2 times root 2, so 1 minus root 2 times root 2 is just 2. So I've got 2 there. And now I want to do my final bit of simplifying. So I will end up with, don't want to use red, 2 plus 4 is 6 plus 4 root 2. And that is all over 1 minus 2, which is negative 1. Now, if our denominator is 1 or negative 1, we want to simplify that further. So 6 divided by negative 1, negative 6. 4 divided by negative 1, negative 4 root 2. And that is our final answer. So that should now be everything you need to do exercise 5 on the question sheet that I've put up as well. As always, if you struggle with any of the questions, please let me know and I can do a video showing you how to work through those questions. Okay.